Let's now define the terms path, circuit and cycle. Path is an ordered sequence of vertices to reach one vertex from another. And if a path does not have any repeating edges and the start and end vertex are same, we call such a path as a circuit. And if such a circuit doesn't have any repeating vertices, we call it's a cycle. Now consider this example. Here, B, C, E, F is a path to reach F from B. And if we consider a path B, C, D, E, F, D, B, it's a circuit, and note that we have start with the vertex B and end vertex also B. Now here, there's no repeating edge, however, vertex D has included twice in this path. So even though this path is a circuit, it's not a cycle because we have repeating vertex. But if we consider B, C, E, F, D, B path, it's a cycle because there's no repeating vertex or no repeating edges. Now let's define what is weighted graph. Graph is called a weighted graph if each edge has an assigned number. Now depending on the context, this number may refer to a cost, weight, distance, length and etc. For example, in case of road network, this weight represents the distance between cities. Graph is called a complete graph if for each pair of distinct vertices has only one edge connecting them. Now below graph is an example for complete graph and it has only one edge between each pair of vertices. We use word adjacent and incident commonly in graph theory. Two vertices called adjacent if there's edge between them. If there's edge between two vertices, we refer that edge is incident with particular vertices. For example, in the below diagram, we can say that edge with 1300 weight is incident with two adjacent vertices, Dallas and Washington, or edge with distance 780 incident with Dallas and Denver adjacent vertex, and so on. One of the most important terms we used in graph theory is a DAG or directed acyclic graph. DAG consists of finitely many vertices and edges with each directed to one vertex from another, such that there's no way to start from one vertex and follow a consistent directed sequence of edges that eventually loops back to that starting vertex. In other words, there will be no directed cycles in a directed acyclic graph. For example, graph in the left side is a DAG because there's no way to start from one vertex and follow a path and come to that start vertex. Graph in the right side, but in the graph in the right side is not a DAG or directed acyclic graph because we can start from C and follow path D, A, B and come to C again, or there's many paths to come to C again, and therefore right side graph is not a directed acyclic graph. So those are the important terms that we need to know to properly understand the graph theory. Now there are few more important terms as well. I will explain to you those whenever they appear. So that's it for this video. Thank you.